What if I told you the James Webb Space Telescope has spotted galaxies that shouldn't even be there? Galaxies that are too massive, too bright, and too organized to exist just 300 million years after the Big Bang. That's like finding a skyscraper in ancient Babylon or a smartphone in the age of the dinosaurs. These findings are so bizarre, they might force scientists to rewrite the very laws that describe our universe. Einstein's theory of relativity, the Big Bang model, they're both on the table. Buckle up, the cosmos is about to surprise us in ways we never expected. To understand why this is such a big deal, we need to rewind the clock, way back to 13.8 billion years ago, the moment of the Big Bang. From this cosmic explosion, space, time, energy, and matter all burst into existence. According to our current model, called the lambda cold dark matter model, or lambda CDM for short, the early universe was a hot soup of particles that took hundreds of millions of years to cool down and begin forming the first stars and galaxies. Under normal conditions, it should have taken at least 1 billion years for massive, structured galaxies to appear. But here's the kicker. JWST, with its unprecedented sensitivity and infrared vision, has found fully formed, massive galaxies that date back to just 300 to 400 million years after the Big Bang. Let me repeat that. We're seeing galaxies that shouldn't exist that early, at least not according to the standard model of cosmology. In early 2023, astronomers studying JWST's deep field surveys stumbled upon what they initially thought were ordinary high redshift galaxies. But when they looked closer, analyzing their mass, luminosity, and structure, they realized something shocking. These galaxies were too big. Some had stellar masses nearly equal to our own Milky Way, but at a time when the universe was less than 5% of its current age. Even more puzzling, they weren't chaotic or clumpy like baby galaxies should be. These were well organized, with evidence of disks, bulges, and complex star populations, features that shouldn't have developed until much later. Scientists were so skeptical that they thought it might be an error in redshift measurement. Maybe these galaxies weren't as old as they seemed, but follow-up studies confirmed it. These galaxies are real, ancient, and evolved. So, what's going on here? Have we just found an edge case? Or is there a flaw in our understanding of the universe? Here's where things get spicy. Einstein's theory of general relativity explains how gravity shapes the universe. It forms the basis of our modern cosmological model. But if the universe is producing galaxies faster than we thought possible, then something's off. Either gravity worked differently in the early universe. Dark matter behaves in unknown ways. Our measurements of cosmic time and distance are flawed. Or we've misunderstood the initial conditions of the universe itself. Some scientists are now exploring modifications to gravity, like MOND, modified Newtonian dynamics, or new types of dark matter that clump more quickly than cold dark matter. Others are considering entirely new cosmological frameworks, such as variable speed of light theories or early dark energy models, where dark energy kicked in earlier and faster, compressing time and accelerating structure formation. And then there's the idea that perhaps the Big Bang wasn't a singular beginning at all. Brace yourself, because this is where science starts to sound like science fiction. Some physicists suggest we might be seeing the remnants of a previous universe, or the scars of a cosmic bounce, where our universe emerged from the collapse of an earlier one. Others propose the multiverse hypothesis, where different regions of space follow different physical laws, And what JWST sees are galaxies from a neighboring universe bleeding into our own. Still others wonder if time itself is an illusion, that what we perceive as billions of years might behave differently at cosmic scales. These aren't just wild YouTube ideas. These theories are being debated in academic journals, physics conferences, and inside the halls of NASA and CERN. If the standard cosmological model breaks, the consequences ripple far beyond astronomy textbooks. Physics would need a revolution. We might need a new Einstein to unify quantum mechanics with gravity and cosmology. AI-based astrophysics could become vital, using machine learning to find new laws hidden in JWST data. Humanity's origin story changes. We're no longer looking at a quiet, slowly evolving universe, but at one far more chaotic, fast-paced, and perhaps alive than we imagined. And let's not forget the implications for space exploration. If the universe evolved faster, then perhaps planets, atmospheres, even life may have emerged earlier than expected. That opens new doors in the search for extraterrestrial intelligence. So, what's the takeaway? James Webb has cracked open the vault of cosmic history. And what's emerging are whispers of a universe far stranger than we ever imagined. A place where galaxies sprint instead of crawl. Where the past is more mature than it should be. And where even Einstein's equations might be just one version of the truth. Is this the beginning of a new era of science? Or the end of our current cosmic story? Whatever the answer, one thing is certain. The universe is no longer playing by the rules. And the deeper we look, the more it seems we were never really in control of the script. If you found this discovery as mind-blowing as I did, make sure to like, share, and subscribe to I Am TechBug, your home for science's biggest mysteries, stunning breakthroughs, and universe-defying questions. And don't forget to tap that bell icon so you never miss an upload.